Hello everybody, welcome into another lesson. Today we are going to talk about multiplying rational expressions. So we will have some fractions with variables in them, but let's start with just some regular fractions. Multiply some regular fractions here. So let's say we have negative 6 sevenths times 2 sevenths. Well, if we recall from basic math, all you have to do with multiplying fractions is you multiply the numerator, you'll get your numerator, then you multiply the denominator. The first thing you want to do though before you multiply, see if there's anything that'll cancel out between the numerator and denominator. And well, there's no factors of 6 that'll cancel out with 7, there's no factors of 2 that'll cancel out with 7, so it's already in its simplest form. Now we just go ahead and multiply. So we got negative 6 times 2, that's negative 12. 7 times 7, that's 49. So the answer you would get for this is negative 12/49. I'm going to do a few numbers here, then we're going to jump into the variable ones. Alright, how about this one? 8 ninths times 27/28. We have 8 ninths times 27/28. Well, we can see that it definitely looks like someone's going to cancel out here. We know the 9 and 27, because 27 divided by 9 is 3, 9 divided by 9 is 1. So the 9 and the 27 will reduce. Now, what we have here is 8 over 1 times 3 over 28. Alright, 3 and 1 are as reduced as they're going to be. How about 8 and 28? Do they have any common factors that'll cancel out? Well, they have a 4, because 4 times 2 is 8. 4 times 2 is 8. That'd be all over 1 times 3. And then 28, well, that's just 4 times 7. Now we see between the numerator and denominator, we have a common 4 that'll cancel out. What you're left with is 2 over 1 times 3 over 7. And then we see it's clearly reduced, so now all you have to do is multiply the numerator and denominator. 2 times 3 is 6, 1 times 7 is 7. So the fraction you're going to get here is 6 sevenths. Now we could have multiplied it just as is, and we would have gotten some god-awful number here in the numerator and the denominator, but that's why I say, look for anything you can cancel first, because it'll make your life a lot easier when you go to multiply. So that's much better. 6 sevenths is much better than trying to reduce it from some god-awful big number. Alright, we have 6 2/3 times 1/2. So you have a mixed number times a fraction. First thing I would do, I would suggest, is change that mixed number into an improper fraction. That mixed number, if we recall from basic math, to change this into a mixed number, you take the denominator times the whole number. So 3 times 6, you would get 18. And then you add the numerator to that result. So 18 plus 2 is 20. You would get 20/3 times 1/2. Now you're reduced down to 20/3 times 1/2. Do we have anything that'll cancel out between the numerator and denominator? We sure do. The 2 will cancel out here, and you can divide 20 by 2, you'll get 10. So what you're left with is 10/3 times 1 over 1, which 1 over 1 is just 1. The answer you would get is 10/3. That's one acceptable answer. If your teacher is okay with leaving it as a mixed, leaving as an improper fraction. If they want the mixed number form, 10/3, well, that would simply be 3 1/3. So it would either be 10/3 or 3 1/3. Either of those would be acceptable. Okay. So those are some numbers that we dealt with. And if you want to know more about multiplying number fractions and mixed numbers and all that, please check my Basic Math 1 playlist where I taught it in great depth. This is just simply a review. But now we're going to move on to some variables here. So we have 4a over 5 times 3 over a. Well, okay, so now we have variables introduced. So 4a over 5 times 3 over a. What should jump out at you right away is there's a common a between the numerator and denominator that'll cancel out. That'll cancel out. Does anything else cancel out? There's no factors of 4 and 5 that'll cancel each other, or 3 and 5, so what you're left with is 4 over 5 times 3 over 1, which then you just multiply numerator and together. 4 times 3 is 12. Then you have 5 times 1, that'd be 5. So your answer would be 12 over 5. That's exactly what you get, is 12 over 5. Alright, let's see. We have 3x over y times 9y over x. So 3x over y times 9y over x. What should jump out at you is the x's will cancel out from numerator and denominator, so will the y's. The y's are gone. You're just simply left now with, well, 3 over 1 times 9 over 1. You have 1 times 1 as your denominator. You don't even have to worry about the denominator. That would just leave you with 3 times 9, which would equal 27. So yes, always before doing the multiplication, look for things that'll cancel out. That's the best way to do these. Just look for things that'll cancel out. Alright, let's see. We have 12 over jk times 3k over 4. So 12 over jk times 3k over 4. What should jump out at you is you have a k in the numerator and in the denominator, meaning the k's will cancel for sure. Anything else jump out? Well, we have 4 and 12. 4 divided by 4 is 1. 12 divided by 4 is 3. So what you're going to be left with here is 3 over j times 3 over 1. Now you just multiply the numerators together. 3 times 3 is 9. J times 1 is j. So the answer is going to be 9 over j. That's what you would get, 9 over j. Alright, I got 3 more. We have 8 over c times c to the second power over 11. So we have 8 over c times c to the second power over 11. Well, what we can do, of course, what we remember here, in this case, since you have variables, the same variable, but you have one to a power and another one that's just to the first power, I would go ahead and do your multiplication. Since the 8 and 11 don't cancel, because yeah, 8 and 11 do not cancel each other at all, there's no factors. I would do the 8c squared over 11c. Okay? If we recall, when we divided powers, that's going to be the same as, you'll still have your 8/11ths, but you'll have c to the second power minus the first power, because when you divide exponents, you subtract you do the power in the numerator minus the power in the denominator. So now you have 8 in the numerator, c to the 2 minus 1, well, that's just c to the first, or just c. Then you have 11. So your answer to this is going to be 8c over 11. That's exactly what you would get, 8c over 11. All right, let's see. We have n over 18 times 6 all over n to the 4th. All right, so we have n over 18 times 6 all over n to the 4th. Well, right away we see 6 and 18 will cancel each other. 6 divided by 6 is 1. 18 divided by 6 is 3. We can't yet cancel any further. We want to deal with these powers of n. So what I would do now is you're going to have n over 3 times 1 all over n to the 4th. Now I would go ahead, multiply these together. N times 1 is n all over, then you have 3 times n to the 4th. That'd be 3n to the 4th. Well, again, when we divide powers, we subtract. That's exactly what we would do. We subtract the powers. So in the numerator, you have n to the 1st. So you have n to the 1st minus the 4th power all over 3. Because, of course, when you divide, you subtract the power. You do the power in the numerator minus the power in the denominator. So n to the 1 minus 4, that's going to be n to the negative 3rd all over 3, which now we have a negative power. That just goes to the denominator, so you'll have 1 all over 3 times n to the 3rd. That's what you would get, because then again, your power, since it's negative, goes to the denominator and becomes positive there. So you'll have 1 all over 3 times n to the negative 3rd. I mean, n to the positive 3rd, excuse me. And that's its reduced form. We can't reduce it any further. All right, one more here. We have x over 2z times 2z squared all over 3. Okay, so we have x over 2z times 2z squared all over 3. Well, immediately we see we have a common 2 that'll cancel. And nothing yet jumps out. Nothing yet jumps out for what can be reduced. So what you're left with is x over z times z squared over 3. Go ahead and do your multiplication. You'll have xz squared over 3z. Because z times 3 is 3z. Okay. Well, the x we can't do a whole heck of a lot about, but we have z squared over z. That means what we have here is x times, we have z to the second power minus z to the first power all over 3. That 3 just stays in the denominator, but the z's, you can subtract the power, which would give you a final answer of x, and then you have z to the 2 minus 1, that's just z, that would be all over 3. And we can't reduce this any further, so your answer for a fraction is xz all over 3. So really, with doing these, it's about, before you multiply, look for what you can cancel out. That's going to help you out a lot. Look for what you can cancel out. And then if it were just plain z in the denominator and plain z in the numerator, the z's would have canceled out. But you have one that's a greater power than the other, especially in the numerator, so you just have to follow the rule of whenever you divide powers, you subtract them. So that's how you arrive there. So there's really not much to these. So next lesson, we're going to do division of rational expressions. Hope everyone has a good day. Take care.